So this is another system of equations, Regents question, where we're tasked with first writing out the system, answering a question about the system, and then solving the system algebraically. Okay, but let's just jump right in. So first off, it tells me that Courtney went to a coffee shop to buy lattes and donuts for her friends. One day she spent a total of 1550. Okay, a lot of numbers here. Okay, so let's start keeping track. 1550 on four lattes and two donuts, right? And then it tells me the next day she spent, what does it say here? 1810 on three lattes and five donuts. Okay, all prices include tax. That's just so that we don't have to worry about dealing with any kind of percents. Now, if X represents the price of one latte, Y represents the price of one donut, write a system of equations that can be used to model the situation. Okay. Now, for the most part, they are pretty fair about putting things in order. So what you notice is that X is lattes, Y is donuts, right? X is lattes. If you don't know what a latte is, it's like a fancy coffee. Y is donuts. Okay. And I'll notice here, right, every time it mentions them, it starts off with lattes first and then donuts. Lattes and donuts. So they're usually not trying to trick you, is if they present the variables in order, they will typically also present the information in that same order. Okay, but it is good to just have your guard up and make sure that you're intentional about matching up the right numbers with the right variables. Okay, now situations like this, most of the time, follow a format that looks something like a number times x plus a number times y is equal to a total. Okay, that's one of the most common forms of questions that we see on the Regents. And this here happens to fit that mold. So x again is the lattes. So what number attached to the lattes in the first one was 4. So 4x plus 2 donuts is y equals my total of 1550. That's my first equation. Second equation follows the same thing. Okay. Is now my new total is 1810. So I like to put the total on the right. And I've got 3 lattes. Again, latte was X. And 5 donuts. Donuts was Y. So this here is my system of equations. And that just scored me 2 points on the Regents. Okay. Now, for this next question, it says Courtney thinks that one latte costs $2.75 and one donut costs $2.25. Is Courtney correct? And justify my answer. Okay. So what it's telling me here is that Courtney is telling us what she thinks X is and what she thinks Y is. Now, pro tip, okay? Down here, it'll tell us to figure out the exact cost algebraically. Okay, so this answer here is pretty much always going to be incorrect. Okay, they're not going to give you the answer here if they're asking you to compute the answer down here. Okay, so I know that Courtney is going to be incorrect. Okay, she's incorrect, but my justification is all I have to do is essentially like check my answer. Okay, imagine that I solved the system. These are the two answers that I got, and I want to verify if they're right. So I stick these answers into here and see if it's true. So is this right for the first one? Okay, is if I take 4 times 2.75 plus 2 times 2.25, is that going to be equal to the 1550 that I know the actual cost was? Okay, now I'm feeling kind of lazy, so I'm going to take this part here, stick it in my handy dandy calculator. Okay, so 4.275. Let's zoom out a little bit here. 4 times 2.75 plus 2 times 2.25 equals, look at that, 15.5, 1550. Now, this actually is a trap, okay? So in this case here, this one actually works out. But if a if coordinate pair is a solution to a system of equations, it needs to work for both of the equations. Okay. So even though it works for this one here, I have to check and see if it works for the second one, which is where I know it's going to fail. So 3 multiplied by 2.75 plus 5 multiplied by 2.25. I need that to be equal to 1810 if Courtney was right. Okay. But I'm going to see here when I put in my calculator, it's going to be incorrect. Okay. But let's just verify that here. So I've got 3 times 2.75 plus 5 times 2.25. That's equal to, oh, there's a problem. That's 1950. Okay. Which is not what it should be equal to. Right? So I know that she's incorrect, and here's my justification here. Okay, so this is equal to 19.50, which is not equal to 18.10. Okay, so I'm going to say here that she's incorrect. And even though my justification is pretty much here with the math, is I do like to explain it verbally as well. Okay, is because the solution does not work for both equations, which is just what I showed mathematically here. But again, pro tip is if they offer a solution to you and ask you if it's correct, and then the very next part, they ask you to solve that question, that solution was not right. Okay. Otherwise, they're not going to ask you to solve it here. But now let's get to solving this guy algebraically. Okay. First off, is algebraic, I should be thinking either I'm going to use substitution. Substitution, got to sound it out sometimes, or elimination. Okay. Now, I tend to go with elimination most of the time for systems like this here because they tend to lend themselves well towards elimination. Okay. Substitution is also going to end up giving you a lot more fractions that you end up having to deal with. Okay. But how do we go over solving this with substitution? Is first off, I'm going to copy my system down over here. Okay. 4x plus 2y equals 1550. I've got 3x plus 5y equals 1810. Now, my goal is to get the variables, okay, the coefficients of the variables to be the same and opposite, okay? Right now, that's not possible. This is a 2, this is a 5, this is a 4, this is a 3. So I'm actually going to have to multiply both of these equations by something. Now, you've got some options, but your first choice is going to be which variable do you want to get rid of? So I'm just going to focus on the x's. So the trick here is I'm going to multiply this equation by this coefficient here. Okay, I'm going to multiply this one by 3, and this equation by that coefficient, 4. But I do want them to be opposites. So I need to make one of these negative. And again, it does not matter which one you make negative. Okay. But I'm going to go ahead and make the top one negative. Okay. Just because this one is small overall. Okay. Overall, it does not matter. I could have made the 4 negative. I also could have multiplied this by 5 and this one by 2 if I was trying to get rid of the y's. Okay. Now, over here, the main things to remember is I'm essentially distributing this to all 3 terms here, including the right-hand side. Okay, so negative 3 times 4, I've got negative 12x. Negative 3 times a positive 2y, I've got minus 6y. And negative 3 times 1550, we're going to get our calculator so we don't make a mistake. And we're going to say negative 3 times 1550 gives us negative 4650. Okay, that's my first equation. Now, same thing with the second one. Okay, 4 times 3x, 12x. No, same and opposite. So these will eliminate. 4 times 5 is plus 20y. And now 4 times 1810, again, handy dandy graphing calculator. Okay, 4 times 1810 gives me 7240. Right. Now again, elimination. So what do I do next is now I add these two guys together. Note, negative 12, positive 12 eliminates. This is what I wanted to happen. Negative 6y plus 20y is going to be 14y is equal to, and on this side here, again, no shame in just sticking this computation into your calculator because you really don't want to end up making a mistake here, right? But I've got 7240, which actually was my answer here, and I'm adding on to it the negative 46.5. Okay, what do I get? 2590. Almost there. Now, my last step here is to simply divide out that coefficient, and I get y is equal to 2590 divided by 14. Okay, so I got 2590 divided by, did I hit that twice? I did. 14. My answer here is $1.85. Okay, $1.85. Again, if we recall, that was the price of the donut, was why. Okay, so I'm halfway done, is I still need to figure out my X value. Okay, now how do I do that? Is I need to take this and substitute it. It doesn't matter which equation, okay, any of these two equations here. I'm just going to stick it into the bottom one. So bring this down now. I've got 3x plus 5. Y, we just figured out, isn't just y, it's 1.85 is equal to 1810. Okay, so first step is just multiply this out. That's just a number. 5 times 1.85, so 1.85 multiplied by 5 is going to give me $9.25. So I've got 3x plus $9.25 is equal to 1810. This is a two-step equation. Subtract that constant from both sides. So 1810 minus 925. Let's see. I got to type it out. All right. So I got 1810 minus 925 gives me $8.85 on the right-hand side. On the left-hand side, I'm still left with a 3x. So my last step is to divide both sides by 3. And let's see what we got here. 885 divided by 3 gets me an answer of $2.95 for the cost of a latte. And that's it. Again, it does look like a lot of work. It does look fairly complicated with all of the decimals there, but we really are relying on that calculator to do a lot of the work itself. Other than that, it's just a basic elimination question, right? But again, that is the last question that is typically found on the Regents. It's usually a 6-point question, and you typically get about 2 points for this part, another 2 points here, another 2 points here, more or less. All right. So get out there and make sure you practice your substitution and your elimination so that you're ready for these types of questions. Good luck.